function that has only one x-intercept and passes through the given point. This question, the only one x-intercept is 5. The point is 4, 3. Here you must be careful. Only one x-intercept and passing through the given point. Okay, first, let's analyze the situation in the Cartesian plane related to the location of a quadratic function. Here the region. We don't need to consider whether the quadratic function's graph opens downwards or upwards. We just need to focus on the location. Here, we assume the function, its graph, opens upwards. So perhaps the function's graph, perhaps here, 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 or here, or here. Okay, we know for this situation, this function has no x-intercepts, and for this situation, this function just has only one x-intercept. For this one, if the vertex of the graph is just on the x-axis, we can say this function has just or only one x-intercept. For these two situations, we can find out they have two x-intercepts, not just only one x-intercept. Of course, perhaps this function, its graph is here. But if you extend the graph in these two directions, finally, it will have two x-intercepts. So for the green situation, we can say it does not have only one x-intercept. So in this graph, we can figure out just for this situation and this situation, the graph has only one x-intercept. That is to say, the function, the graph, the vertex is just on the x-axis. You don't need to consider whether the graph opens upwards or downwards. It can be here. It can be here if the function's graph opens downwards. So we can figure out if the quadratic function just has only one x-intercept, we can get the conclusion. The vertex of the function, the vertex must be on x-axis. Okay, if the vertex is on the x-axis, we can figure out the vertex, the x-coordinate is 5. So we figure out x equals 5. The corresponding y-coordinate of the vertex, it should be y equals 0. So the vertex, its coordinate should be 5, 0. Okay, and simultaneously, we know this function, it also passes through this given point. It is 4, 3. So we have 2 points on this graph. Okay. From this information, what can we do? Okay, because we have known for the function fx equals ax squared plus bx plus c, the vertex, that is to say, x equals 5, meaning for this function, the axis of symmetry, we say axis of symmetry, it should be x equals negative b over 2a. This b is this one, a is this one. So we figure out b over 2a equals 5. If x equals 5, we can figure out fx equals a times 5 squared plus b times 5 plus c. It should be equals 0. This one. Okay, so we can figure out 25a plus 5b plus c equals 0. Okay, and this is the first equation. This is the second equation. We mark them, this one and this one. Okay, additionally, we know this point is just on this functions graph. So x equals 4, y equals 3. So we just need to plug in these values into this equation. We can figure out fx is just 3 equals 4, a times 4 squared plus b times 4 plus c. Okay, we can figure out 16a plus 4b plus c equals 3. This is the equation 3. So we figure out 3 equations. Now we can construct the system of equations. The first one, the second one, the third one. Okay, we have 3 equations. We can make use of this one and this one to figure out the following relation. That is to say, we use equation 2 minus equation 3, we can figure out 9a plus b equals negative 3. Okay, equation 4. From the first equation, we can figure out b equals negative 10 times a. That is to say, this one, we can figure out this one. So from this equation and this equation, we can figure out the following value of a. That is to say, we can use this one to replace b. So we get 9a minus 10a equals negative 3. So we get a equals 3. So b equals negative 30. C equals, you can plug in these two values back into this equation or this equation. You can figure out C. Now I plug in these two values into this equation. So 75 minus 150 plus C equals 0. So C equals positive 75. C equals this one. Okay. Then we can write out the original equation. It should be fx equals 3x squared plus, here it should be minus 30x plus 75. Okay, this is the quadratic function which has only one x-intercept and passes through the given point. That's it.